In the previous lesson, we talked about angle pairs on lines that are intersected by a transversal. So we talked about if I have two lines that are intersected by this transversal, that angles such as these two, for instance, same side of the transversal, one is interior, one is exterior, and they each have their own vertex. These are called corresponding angles. Okay, then we talked about if we have two lines that intersect with a transversal, that these angles would be alternate interior angles. These two right here, they're on alternating sides of the transversal. They have they're both interior and they both each have their own different vertex. So those are alternate interior. Then we talked about alternate exterior, where these angles are alternate exterior. An example of alternate exterior, they're not the only ones. And then those are on alternating sides of the transversal. Both of them are external and each of them has their own vertex. And then we talked about angles that look like this. They are same side interior angles because they're on the same side of the transversal and they're both interior to the lines that are being cut by the transversal. So those are our four angles. We also were reminded about linear pairs. So a linear pair is where two lines intersect and they are adjacent and they are supplementary. So these are a linear pair. Notice that there are only two lines in the picture, so they're not the three that are the one transversal with the two lines that cross it, at least two lines. And then we also talked about vertical angles. And vertical angles are always congruent, so those two angles are congruent. And then these two angles are vertical and they are congruent. So those are the 6 angle pairs that are going to be important in this unit. Excuse me. So with every one of these angle pairs that was formed by the transversal, it didn't matter about how the lines were laid out. It just mattered where the angles were in comparison to the transversal and the two other lines. So what happens then when the lines are parallel? Well, what happens when the lines are parallel is that corresponding angles become congruent. Now, they can be corresponding without having to be congruent. But what makes them congruent is that the lines are parallel. Also, if lines are parallel, then alternate interior angles are congruent. Also, alternate exterior angles are congruent. And then lastly, if the lines are parallel, only if the lines are parallel, then the same side interior angles are supplementary. And I will explain why when we do our picture, when we set up this graphic. So the first thing, let's mark our corresponding angles. So our corresponding angles, remember, they're on the same side of the transversal. One is inside, one is outside. So these are corresponding. They're not the only corresponding angles in the picture, but they're the two that we're going to mark today. Then we have alternate exterior angles. Our alternate exterior angles, we won't need this whole thing. We can just use the whole piece. We won't need the inside piece today. So those are alternate exterior angles. There are actually 2 pairs of alternate exterior angles, but we only need those. Then we've got vertical angles. Remember, vertical angles are not determined by the transversal, but these two then would be our vertical angles. And I don't need the inside piece of that one either, so we'll just use the whole big thing. So those two are vertical angles. Then we have same side interior angles, and I'll explain why they are supplementary in just a second. Same side supplementary, so I have this one and this one. Those are same side supplementary. And then we have alternate interior. So our alternate interior are right here. Now, I said that I would go back and explain why same side interior are supplementary. Well, they are supplementary because of this right here. Look at this pink and this yellow angle. Those form a linear pair. So that means that they add to 180 degrees. Well, if we look here, we've got another set of pink and yellow angles. Well, since that pink angle is the same in both sides because it's alternate interior, if it's supplementary with the yellow when they're down here, then it's also supplementary with it when it's over here. Well, if you notice, this yellow angle and this pink angle, they are same side interior angles. And so that is why all same side interior angles are supplementary, because we can work through the other information that we have and work that out. So let's apply these to some problems. So it's important, I think it's helpful to highlight your parallel lines. So we have our parallel lines and we have our transversal. So you want to look at what you have. So I have this transversal here, okay? I have this 53-degree angle. It has this vertex right here. So you have some choices here of how you want to start. You can start with angle 2 or you can start with angle 1. It depends on which one you see first. If you saw angle 1 first, then you would know that angle 1 and angle 53 are corresponding angles. And so that means that angle 1 has to also be 53 degrees because they're corresponding. Now, you might have seen angle 2 first and recognized that angle 2 and 53 degrees are a linear pair. So if they're a linear pair, you would take 180 and subtract 53 and get 127. Okay, so you would have 180 minus 53 is 127. Now, the other way you could do that is you could see this same side interior angle. Same side interior angles are supplementary. Okay, so you just want to kind of get to where you look for your parallel lines and your one transversal. So always look for that so that you can figure out where to go. So you can decide on all of these. Some of them, you just got to just put something out there and try it until you get to a stopping point, and then look for something else. So just start filling in everything you know. So in this one, it doesn't matter whether you start with angle 1 or angle 2. Again, let's start with angle 1. So angle 1 is formed by this side and this line, and 50, we got to use an angle that we know. So if I highlight those two, then I have that this is my transversal, and here are my two lines in question. And what I see is those are same side supplementary angles, or same side interior angles. And if the lines are parallel, then those angles have to add up to 180. So I would take 180 and I would subtract 50, and I would find out that angle 1 is 130. I can use that same idea if I go over here to this 82-degree angle. So it might help too to look at this, like take this angle and its vertex and then slide it across a transversal. Okay, so we slide up this transversal and we want to go to another parallel line. We could go back to this 50, but that doesn't do any good because we're not sliding to parallel lines. We need to deal with parallel lines. So we're going to take this point and we're going to push it up here to angle 2. Well, what I see is that angle 2 right here, it's on the other side of the transversal, and it's interior, and alternate interior angles are congruent whenever the lines are parallel. So that means that angle 2 is 82 degrees. Now, angle 1, I need to point this out because I don't want you to make this mistake. Do not do this. Angle 1 and angle 2 are not supplementary angles. They are not supplementary angles because they share this side right here. They share this side, that's just the transversal. Those other two lines are not parallel. So angles are only congruent and supplementary when the lines are parallel. So neither one of those two lines is parallel, so angle 1 and angle 2 are not supplementary, but that mistake is made so often, so don't do that. So if we look at angle 3, we're going to start here with this 98 degrees. We always want to start with what we know. So we start with that 98 degrees. Now, there are so many different ways that you can start. The only one that you cannot start with is angle 4. That's the only one that you can't do from the beginning. Every other angle you can do from the beginning. So you have some choices. But the first thing I see, the one I usually start with is vertical angles, so that I know that angle 3 is vertical with that 98-degree angle. Then I know that angle 1 is supplementary. It's a linear pair with this 98 degrees. So I know that this is 82 degrees. 180 minus 98 is 82. Then from there, I know angle 2, either because it's vertical or also because it's a linear pair, either one. So now I have finished everything I can finish on this vertex. I need to slide down this transversal and find them on this vertex. You have so many different options here. You can use alternate interior and find out that this is 98 and this alternate interior to see that that's 82. Or you can use all corresponding angles, and you can take everything that's on this top plus and imagine just sliding it down on top of that bottom plus so that 3 matches with 6, 2 matches with 4, 1 matches with 7, and 5 matches with 98. Okay? Now I'm not going to take the time to go fill in the blanks, but I think it's helpful to label it on the picture so that you don't have to remember things in your head. Just write them down so that then you'll see things like vertical angles and linear pairs. So number 4, just to make sure I didn't point it out earlier, these arrows like that, those mean that those two lines are parallel. And these arrows means that those two lines are parallel. So we're going to start working our way along these parallel lines. So I've got these two parallel lines here, and then let me do these in a different color so we can keep them straight. I've got these two parallel lines. So if I look here at angle 40, this 40-degree angle, that's where I started. I want to start working my way around. So from this one vertex, I'm going to look over here between those two green lines along that red transversal. And I notice that this 40 and this A are on this alternate interior angle. So since those lines are parallel, I know then that angle A has to be 40 degrees. Okay, so I've kind of exhausted all of my options there, so I need to work and go down to this vertex between the two red parallel lines and the green transversal. So I notice that this is 40 degrees, and it is corresponding with E, and so that means that E is 40 degrees, so I label it in the picture. From there, I can find C and D. D is a linear pair with E. Right here, I've got my linear pair. And so D is 140 degrees. C is also 140 degrees because it's vertical, or it's a linear pair with 40. And then now I have to work. Now, you cannot go from that original 40-degree angle over to B and F. Remember, we talked about you have to go down one transversal and then switch to the other. So now I'm going to switch, and I'm going to work from this vertex over to here because I can't go back to the 40, although the 40 is influencing everything. So now I'm working between the two green parallel lines, so I'm working with this piece. Okay, so I look and I notice that E, this angle, 40-degree angle right here, is on the alternate side of that red transversal with F, which means that F has to be 40 degrees. And then from there, I look and B is either corresponding or it's vertical with F. So it's corresponding with E or it's vertical with F. So either way, B is 40 degrees. All of those are degree symbols. So you have to work your way around from one vertex to another, and you just need to learn to isolate two lines and one transversal at a time. So 5, check 5 for a minute, look at it and see where you want to start, because there are several different ways you can start. You can start with X, you can start with Z, or you can start with Y. In my experience, most students want to start with Y because they see that vertical angle first. And so they see then that Y must be 60, which is exactly right. Okay, so then we need to go somewhere else. We did all we could with that, so now we need to look at something else. So I know that I have this angle right here, this 75-degree angle, and I want to take that transversal, or that vertex, and I'm going to slide it down the transversal until I get to another vertex, and I want to see what matches. I want to look for something that matches. Well, I notice that this Z is in the same place as that 75 is. It's on the same side of the transversal. The 75 is interior and the Z is exterior, which means that Z is 75 also, because if the lines are parallel, corresponding angles are congruent. That just leaves me with X, and I have two choices with X, but I think the way that you would probably choose to do it is that those three angles form a straight angle, which means they equal 180 degrees. So if I take 60 and add 75, then I get 135. If I take 180 and subtract 135, I get 45 degrees. So that X is 45 degrees. Now, just so you can see it, just so I can show you, you could have also done this and used these pieces. Notice that this angle and this whole big angle are same side interior angles. Since those lines are parallel, those same side interior angles have to add up to 180. Well, if the three pieces already have 2, I would do the exact same math I did with the supplementary. It was just a different reasoning behind it. So angle X, or the angle that was represented with X, is 45 degrees, Y was 60 degrees, and Z was 75 degrees. So again, you can be corresponding, right? Angles can be corresponding and not be congruent. These two angles are corresponding, but they're not congruent. But as soon as I make those lines parallel, then those angles become congruent. And so having those parallel lines gives us a lot of room to solve these problems. And don't forget vertical angles and linear pairs. So we need all 6 of these angle pairs to solve these problems. But the linear pairs and the vertical angles do not come from the parallel lines. They come